All right, so we are looking at how to complete lesson 2, polar ice. Um, so this assignment was when we looked at land ice versus sea ice and which one raised sea levels. And remember, the land ice raised sea levels because that water, that mass of water, is not already part of the ocean. So when it melts, that mass is being added to the ocean. Whereas with the sea ice, when we put the ice in the water, that water mass is already part of the ocean. It's already raising sea levels. In the same way, if you have a cup and you put some ice in it, and you can see, sure, most of the ice is underneath the water. Some of it might be poking out a little bit, but you're still displacing that water level as you put ice cubes into the water. So for this assignment, what we did was we laid out the procedures for our lab. And remember, we had two models. We had two bins. In each bin, we glued styrofoam in the bottom. In one of them, we put clay on top of the styrofoam. The other one, we didn't. We filled up the bins about halfway up the styrofoam with water. And then on the land ice model, we put the ice cube on the clay. And in the sea ice model, we put the ice cube in the water, so that we could figure out, after time passes, how much does sea level rise, or does either of them cause sea level rise? So basically what you're doing here is writing the procedure for it. Remember to include the part where we waited a couple days to see what our results would be. Your sea ice testing system, you're drawing that system from a side view for what that looks like. I'm going to try out this drawing tool and see if I can show you kind of vaguely what your drawing should look like. Let's say that this is the sea ice one, so we'll draw our ice cube here. We can color it in a little bit. So basically, I'm looking for something like this. I would hope that yours is at least labeled. Label the land, label the water, label the ice. But that's pretty much what I'm looking for there. Let's make that go away. And you'll do the same thing for the land ice model down below. So after that, your data, this is whatever data you got. If you don't have the data from the lab, I would get it from someone that you worked with. If you really can't find it, just know that land ice increased sea levels and sea ice did not increase sea levels. Yeah, and then we calculated the difference. Revise your bucket model to explain the results of the investigation. Not the biggest fan of this modeling, but essentially what they want you to see and what they want you to show is that, again, land ice water, like that frozen water, is not already part of the ocean. So when it melts and it goes in the ocean, you're adding mass to the ocean. Whereas with the sea ice, the ice is already in the water, it's already displacing water. It does not make a big difference on sea level rise because that sea level is already risen, however much that ice would displace the water. Let's see, update your bucket model. That's kind of what that was. I mean, if that, write that, that's the explanation that you would put up there. Describe the process that might be causing the water to move from those buckets to Greenland. Basically, it's just asking, how does water get from the ocean to Greenland? Well, it's either raining or it's snowing or, hailing and that ice is freezing over the land. And then here, it's asking you, look at your larger graph and you will see that it shows a net loss of ice over time. So use and or revise your bucket model to explain how there could be a net loss of ice over time. Basically, if the ice sheets are continuing to freeze and build up ice and continuing to melt, depending on the time of year, what does it mean for there to be a net loss of ice over time and why does that happen? So ultimately, it's because, yes, there is more ice being formed every year. Yes, there's ice melting, but there's far more ice melting than there is ice freezing. So that's how there's a net loss of ice over time. More ice melts than it does freezing. Can our mathematical model predict the amount of sea level rise? What was the volume in centimeters cubed of the land ice your group started with before it melted? So here you're calculating the volume of the ice cube. I believe they were 2 inches by 2 inches by 2 inches. Or maybe, no, I'm sorry, it was 2 centimeters by 2 centimeters by 2 centimeters. Remember, volume is length times width times height. So you could do that here, and 2 times 2 times 2 is what, 8? So 8 centimeters cubed. B, what is the area of the container of the bottom? This one, I believe our containers, I think we said they were 11 centimeters by 11 centimeters. So you're going to take that whole area, but remember, half of it was covered by the styrofoam. So whatever you find that area to be, you have to take half of that because the other half was the styrofoam. How much should the ice melt from A rise? How much should the ice melt from A raise the water level in B? I don't know what the number is off the top of my head, but basically you're going to take, I wish there was a typing tool on here. Basically, you're going to take the volume of the ice and divide it by the area of the container. So sea level rise equals volume of the ice divided by the area of the container. So you're going to take your answer here, what was the volume of ice, divided by the area you calculated, and that's what your answer here is going to be. How does your answer to C compare to the amount of water actually rose in the investigation? It depends on if you have data or not. Did what you would have expected or what the math expects? Did that match up with what actually happened? And if not, I mean, that's totally fine. Just think about reasons why that might not be adding up. And then E, do you think this sort of mathematical model could help us predict a reasonable estimate for how much the sea levels on Earth would rise from any amount of land ice melt and why? Yes. By now, I would hope that you would figure out that the answer is yes, just because we've done it several times. We do it on the lesson 3 sheet, but basically, yes, if we know the volume of of Greenland and all of the rest of the ice that's on land, we can divide that by the area of the ocean or the area of the container, and we can figure out how much sea levels would rise. And I want to say if it was just Greenland, I think in the next lesson we figured out it's about 6.8 meters. So that's how you complete lesson 2, and that's just kind of a brief overview of it. If you have questions, let me know, email me, and we can figure it out. But there you go. Great job.